database management system. In the previous chapter, we have discussed about the global positioning system, what are the signalings in the GPS, what are the different errors that can occur in GPS, and we also discussed about how GPS is used in various fields right from the military to civilian, navigation to environmental prediction, its vital role in disaster management. Objectives. In this chapter, we will discuss about what is database management system, the history of database management system, components of database management system, features of database management system, advantages and disadvantages. Database management system. A DBMS is a collection of interrelated data and a set of programs to access those data. This is a collection of related data with an implicit meaning and hence is a database. The collection of data, usually referred to as a database, contains information relevant to an enterprise. The primary goal of the DBMS is to provide a way to store and retrieve database information that is both convenient and efficient. By data, we mean the main facts that can be recorded and they have implicit meaning. Management of GIS data consists of storing of variety of data categorized under two types, that is spatial data and attribute data, in a way that permits us to retrieve or display any combination of these data after analysis and manipulation. In order to perform these operations, the computer is able to store, locate, retrieve, analyze and manipulate the raw data which has been collected from the number of sources by using representational file structure. In other words, each graphical identity must be stored explicitly along with its attribute so that we can retrieve and select the correct combination of entities and attributes in a reasonable time. GIS database and a linkage mechanism for their topology to show the relationship between the spatial data and attribute data for further analysis. Database management system is a computerized record keeping system. It is a depository or a container for collection of a computer data files. The overall purpose of database management system is to allow the user to define, store, retrieve and update the information contained in the database on demand. Information can be anything that is significant to any individual or organization. Database management system is classified based on data structure or data types. It is a set of pre-written programs that are used to store or update, retrieve database. The database management system accepts requests for data from the application program and instructs the operating system, which can change much more easily as the organization information requires change. New categories of data can be added to the database without disrupting to the existing system. Organization may use one kind of database management system for daily transaction processing and then move the detail on the another computer that uses another database management system, better suited for random inquiries and analysis. Overall system design discussions are performed by data administrator and system analyst. Detailed database design is performed by database administrator. Database servers are computers that the actual database and run along the database management system, and related software as database servers are usually a multiprocessor computers with generous memory and RAID disk. Hardware database axial RAIDs connected to one or more servers via high speed channel are also used in large volume transaction processing environment. Database management systems are found at the heart of most database applications. Sometimes database management systems are built around a private multitasking kernel with built-in network support, although nowadays these functions are left to the operating system. Special database describes a collection of entities, some of which have a permanent location on some globe and dimensional space. Normally, there is a mixture of spatial and spatial entity types. Spatial entity types have the basic upper graphical properties of location, dimension and shape, while the aspatial entity types do not have location. Thus, before the analysis can be done, additional data need to be specified and incorporated in the geographical database period. To the management, the guise it is useful to examine the concept of database management system. History of database management system. Database have a history of early days of electronic computer. In majority of the older system were linked to the custom database. In order to gain speed at the expense of flexibility, originally database management were found only in large organization with the computer hardware needed to support large data sets. By mid-1960, the number of general purpose database systems emerged in commercial use. COBOL was created by Database Task Group within CODASIL. In 1971, the CODASIL approach was based on the manual navigation of a linked data set which was formed into a larger network. In 1968, IBM had also developed their own database management system known as IMS. IMS was it developed of software within for Apollo program. Both concepts later became known as navigational database due to the way the data was accessed. Thus started the network database. In 1970s, relational database management system was started. Edgar Cordon in 1970 gave a new approach, a relational model of data for large shared data banks. The relational model stored data in tabular form, making it easy for database to retrieve information on particular data at the level of the table rather than looping the whole database. Cord's solution to this necessary looping was set-originated language, a suggestion that would later spawn the ubiquitous SQL. Later, in 1973, Increase was developed by Eugene Wrong and Michael Stonebraker. In the end, 1970s, IBM started working on the prototype system loosely based on the Cord's concept as System R. Components of database management system. Database management system engine accesses logical requests from various other database management subsystems, converts them into physical equivalent and actually access the database and the data dictionary as they exist on the storage device. Data definition subsystem. This helps user to create and maintain the data dictionary and define the structure of the files in the database. Data manipulation. The subsystem helps the user to add, change and delete information in a database and query it for valuable information. Software tools within the data manipulation system are most often the primary interface between the user and the information contained in the database. It allows user to specify its logical information requirements. Application generation subsystem. It facilitates to help user to develop transaction intensive application. It usually requires that user performing detailed series of tasks to process a transaction. It facilitates easy to use data entry, screens come up programming language and interfaces. Data administration subsystem. This component helps user to manage the overall database environment by providing facilities for backup and recovery, security management, query optimization, concurrency control, and change management. To perform the above task, one must have a database professional and manipulation required as variety of the users types processing a large of skill and experience as well as variable needs or requirements in terms of frequency and flexibility of access. To retrieve the required data from the database, mapping must be made between the high-level objects in the query language statements and the physical location of the data on the storage device. These mapping are made using the system catalogs needed to access the database management system. Data is handled by the stored data manager, which is called the operating system, for control of the physical access to storage devices. The database management system has a query complex which makes all the queries optimizer to optimize the code so that the performance on the retrieval is improved. The logical item of interaction within the database is the transaction, which broadly means to create, modify, and delete. Database management system features and capabilities. Alternatively, and especially in connection with the relation model of database management system, the relation between the attributes drawn from a specified set of domains can be seen as being primary. Throughout the recent history, specialized databases have existed for scientific, geospatial, image and document storage and like users. Functionality drawn from such application has begun appearing in the mainstream database management as well. However, the main focus there, at least when aimed at a commercial data processing market, is still on descriptive attributes, on repetitive record structures. The features commonly offered by database management system queryability. Querying is a process of requesting an attribute information from the various perspective and the combination of factors. Example, how many double storage buildings are present in Hyderabad? A database query language and the report writer allows user to interactively interrogate the database, analyze its data and update it according to the user privileges on data. Backup and replication. Copies of attributes need to be made regularly in case the primary disk or other equipment fails. Of periodic copy of attributes may also be created for a distance organization that cannot readily access the original. Database management system usually provide utilities to facilitate the process of extracting the n-disseminating attribute set. When data is replicated between the database servers so that the information remains consistent throughout the database system and users cannot tell or even know which server in the database management system they are using, the system is set to exhibit replication transparency. Rule of enforcement. Often one wants to apply rules to attribute so that the attributes are clean and reliable. For example, if someone says each building in Hyderabad is consisting only 2 floors associated with it, that is identified by house number. If somebody tries to associate the second house number with the given building, the database management system have to deny such request and display an error message. However, with changes in the model specification, such as in this example, if building has different houses on the floors, then rules may need to change. Ideally, such rules should be able to add and remove as needed without significant data layout redesign. Security. There are common computation requests on attributes such as counting, summing, averaging, sorting, grouping, cross-referencing, etc. Rather than have each computer application implement these from scratch, they can rely on database management system to apply such calculations. Computation. There are common computation requests on such attributes such as counting, summing, averaging, sorting, grouping, cross-referencing, etc. Rather than have each computer application implement these from scratch, they can rely on database management system to apply such calculations. Change in access login. Often one wants to know about access to the attributes, what was the change and when was it changed. Logged services allow this by keeping a record of access occurrences and changes. Automated optimization. If there are frequently occurring usage patterns or requests, some database management system can adjust themselves to improve the speed of those interactions. In some cases, the database management system will nearly provide tools to monitor performance, allowing a human expert to make the necessary adjustment after reviewing the statistics collected. Metadata repository. Metadata is a data describing data. For example, the listing that describes what attributes are allowed to be in the data set is called meta information. The metadata is also known as data about data. Advantages and disadvantages of database management system. Using a database management system to manage data has many advantages. Data independence application program should be as independent as possible from details of data representation and storage. The database management system can provide an abstract view of the data to insulate application code from such details. Efficient data access. A database management system utilizes a variety of sophisticated techniques to store and retrieve data efficiently. This feature is especially important if the data is stored on external storage device. Data integrity and security. If data is always accessed through the database management system, the database management system can enforce integrity constraints on the data. For example, before inserting salary information for an employee, the database management system can check the department budget is not exceeding. Also, the database management system can enforce access control that govern what data is visible to different classes of users. Data administration. When several users share the data, centralizing the administration of the data can offer significant improvements. Experienced professionals who understand the nature of the data being managed and how different groups of users use it can be responsible for organizing the data representation to minimize redundancy and turning the storage of the data to make retrieval efficient. concurrent access and crash recovery. The database management system schedules concurrent accesses to the data in such a manner that the user can think of the data as being accessed by only one user at the time period. Further, the database management system protects user from the effects of system failures. Reduced application development time. Clearly, the database management system supports many important functions that are common to many applications accessing data stored in database management system. This, in conjunction with the high-level interfaces to the data, facilitate quick development of application. Such applications are also likely to be more robust than applications developed from scratch because many important tasks are handled by a database management system instead of being implemented by the application. Disadvantages of database management system. Danger of overkill. For small and simple application, for single user database system is often not advisable. Complexity. The database management system creates additional complexity and requirements. The supply and operation of a database management system with several users and database is quite costly and demanding. Qualified personnel. The professional operation of a database system requires approximately trained staff. Without a qualified database administrator, nothing will work for long. Cost. Though the use of the database system, new costs are generated for the system itself, but also for additional hardware and more complex handling of the system. Lower efficiency. A database system is a multi-user software which is often less efficient than the specialized software which is produced and optimized exactly for one problem. Database management system is a complex piece of software optimized for certain kinds of workload, for example, answering complex query or handling many concurrent requests, and its performance may not be adequate for certain specialized operation. Example includes application with tight real-time constraint or applications with just a few well-designed critical operations for which efficient custom code must be written. Another reason for the not using a database management system is that the application may need to manipulate the data in ways not supported by the query language. In such a situation, the abstract view of the data presented by the database management system does not match the application needed and actually gets in the way. As an example, relational database do not support the flexible analysis of text data. Its specialized performance or data manipulation requirements are central to an application. Application may choose not to use the database management system, especially if the added benefits of the database management system are not required. In most situations, calling for large-scale data management, however, database management have become an indispensable tool. Instances and schemas. Databases change over time as information is inserted and deleted. The collection of information stored in the database is right particular moment is called an instance of the database. The overall design of the database is called the database schema. Schema are changed infrequently if at all. The concept of the database schema and instances can be understood by analog to a program written in a programming language. A database schema corresponds to a variable declarations in a program. Each variable has a particular value at a given instance. Read the value of the variable in a program at a point in a time correspondence to an instance of the database schema. Database systems have several schemas partitioned according to the level of abstraction. The physical schema describes the database design at physical level, while the logical schema describes the database design at the logical level. A database may also have several schemas at the time or at the level, sometimes called subschemas, that describes different views of the database. Of these, the logical schema is by far the most important in terms of its effects on application programs, since the programmers construct application by using the logical schema. The physical schema is hidden beneath the logical schema and can usually be changed easily without affecting the application programs. Application programs are set to exhibit physical data independence if they do not depend on the physical schema and thus need to be written if the physical schema changes. Database management system is a collection of interrelated data in a set of programs to access those data. This is a collection of related data with an implicit meaning and hence is a database. The collection of data, usually referred to as a database, contains information relevant to an enterprise. The primary goal of the database management system is to provide a way to store and retrieve database information that is both convenient and efficient. In this chapter, we understood about what is a database management, how the database management is being developed from the period of time, and how the database management features and capabilities are present, and the advantages and the disadvantages of the database management system.